If you heard someone talking about infinity, what would you think they meant? Most people think infinity means that it goes on forever. But technically speaking, infinity is a little more complicated than that. So let's start with sets. A set is just a group of elements. The number of elements in a set is also known as that set's cardinality. All sets with a fixed amount of elements are considered to be finite. Even a set with no elements, also known as an empty set, is still a finite set. If we compare the set of days of the week that contain the letter A to the set of the days of the week that end in the letter Y, they would look identical, and therefore these sets would be equal to each other. If we compared the set of days of the week with the set of the 7 deadly sins, they wouldn't be identical and thus wouldn't be equal. But both sets do have a cardinality of 7, and when two sets have the same cardinality, those sets are called equivalent. Now, suppose our set isn't days of the week, but instead just days. All days, say from the year 1900 onward. Each element would be a date, and the dates would never stop being counted. This set of days after 1900 would be considered an infinite set, because it has an infinite number of elements that never stop being counted. Now, here's the hard question. What's the cardinality of this infinite set? Mathematicians have been asking this question for a long time. The first concept of infinity came from looking at our simplest and oldest set, the natural numbers. Those are the counting numbers, starting with 1, 2, 3, and going on forever. And early mathematicians said its cardinality was infinite, or more accurately, countably infinite. The word countable here is kind of confusing, because we know we could never count all the natural numbers. They go on forever. It's sometimes easier to think of countable here as meaning listable. To be more precise in their work, mathematicians created a symbol to represent the cardinality of the natural numbers. Aleph 0, the smallest type of infinity. Now, let's look at the integers. All whole numbers, both negative and positive. At first thought, it would seem that it would be twice as large as the cardinality of the natural numbers, because instead of going on infinitely in one direction, it goes on in two directions. Here's where things get tricky. When comparing the size of infinity, we are looking to see if the set of integers is countable or listable. If it is, then it is countably infinite, just like the set of natural numbers. We know how to list the natural numbers, 1, 2, 3, 4, and so on, but could we count the integers in the same way? Can we pair up the elements in both sets in perfect correspondence without leaving any out? Mathematicians realized we could. If we start with 0, then go to 1, but then jump back to -1, and then back to 2, then -2, 3, -3, and so on. By counting this way, no elements are left out, and both sets are counted off infinitely in perfect correspondence. This is called a one-to-one correspondence, or a bijection. When two sets have a bijection, we can know they have the same cardinality without ever counting all of their elements. So, while at first it may have looked like the integers were twice as large as the natural numbers, in reality, both sets have the same exact cardinality, Aleph 0. We can also find that the cardinality of the rational numbers is Aleph 0 by counting diagonals across a grid of all possible decimals or fractions. So, is there any other type of infinity? How about the set of real numbers, which includes not only the rational numbers, but the set of irrational numbers, such as pi? If we try to list this set and create a bijection with the natural numbers, we find it is impossible. And not just us low-level math beginners. The best and brightest mathematicians still have not found a bijection. Because we haven't found a way to list this set in a bijection yet, it is called uncountably infinite, and it is the next level of infinity, Aleph 1. Think you can find a bijection with the real numbers? Give it a try. You might just end up making history.